Scientists study and analyze data so they can construct explanations about natural phenomena like volcanoes. Is there any pattern to volcanoes? In other words, if you're to look geographically, is there any specific region in which they're found? They're also interested in looking at earthquakes and other natural phenomena like that, which have tremendous societal costs. This photograph here is a picture of the Northridge earthquake near the university where this team works. These are apartment complexes that were destroyed in the 1994 quake. And historically, California has suffered, of course, the San Francisco quakes earlier the last century. And the question is there any pattern to these quakes? Is there any way we can figure out when and where they're going to occur? And engineers are in the business of designing solutions for the problems caused by such natural events. And CSCS provides a great opportunity to engage students in the process of designing solutions. One of the 8 engineering and science practices mentioned in Dimension 1 of the NGSS is the ability to construct explanations and to design solutions. And so to illustrate how CSCS can be used in the classroom to do this, we're going to use a CSCS lesson here focusing on earthquakes and volcanoes. We'll focus really on the purpose of constructing explanations for why earthquakes occur in a particular zone and are they related to volcanoes. And so in this particular activity, students are given lists of earthquakes. And so as they look at some of those lists, they could look at the largest earthquakes ever recorded, or they could look at a list here of the costliest earthquakes or the deadliest earthquakes. And as they plot these on a map, they could use just a regular wall map to do this. They will see if there are any kind of patterns, first of all. In other words, before you're going to construct an explanation, you have to see if there's any pattern. They could then do the same thing with volcanoes. Or the instructor could do that as well. So for example, the instructor might take data from the students and say, okay, can they name some volcanoes? And so as they name Mount St. Helens and Shasta and Mount Rainier or Mount Fuji, and maybe some of the Kamchatka Peninsula and the Aleutian Islands and so forth, they would start to see perhaps a pattern developing. So again, they could do this themselves, maybe working with a big wall map as they're plotting various different volcanoes and earthquakes. Or we could also have them plot them on a collaborative map. Now, this is a collaborative map to which students have the ability to place pins on this map. So this is just simply a Google map, which we have put under My Maps. And each one of these represents a massive volcano in this particular case. So these are all ones that are magnitude 8 or greater. And so the whole idea is that do they see any kind of pattern in these? And then after plotting these and volcanoes, they're asked in a quick write to basically describe any patterns that they see. So here's some student inputs, and these are some of the correlations or observations that they've made. So for example, Carly seems to say that earthquakes and volcanoes follow each other around the world. In other words, these tend to be associated with each other. Elba's mentioning that there seems to be a strong association with the Pacific Ocean, particularly the rim of the Pacific Ocean, I imagine. Henry's saying that volcanoes and earthquakes are oftentimes on islands. Monica is mentioning that they follow in linear patterns. And so as we look through all of these, we're seeing that people make these observations and try to find some patterns in them, and from those try to construct some explanations. Now, when students do this, they start to get patterns which look strangely familiar if you've ever looked at a map of the tectonic plates. And they'll see that the boundaries of the tectonic plates tend to be associated fairly closely with the occurrence of earthquakes and volcanoes. And so from this point, they're working through a CSCS method where each one is plotting a few points on this map, then looking at that aggregate data and saying, are there any patterns? And from those patterns, can we understand something about earthquake behavior and volcanic behavior and be able to make predictions about where some may occur in the future?